Alrighty. Well, thanks for coming out on this wonderful evening and sitting inside. It seems like the perfect night to be out on the patio enjoying the weather. But it's too hot, and it has been getting hotter. So one of the things I want to do is take a look at what's going on in the Southwest and put it into perspective what's going on to our, with respect to our globe. And I do my talks slightly different depending on where I'm at. Today I decided what I wanted to do is insert quite a bit of what's in the news, as well as the talk I normally give, which is global climate change, what does it mean for the Southwest? So what's in the news turns out to be very relevant for us. And I want to go back to this last fall when New York Times, both the New York Times Magazine and one of their other sections, started taking note of what's going on out here in the West. And what's probably one of the most noticeable things, and I'll call it poster child for climate change throughout this talk, is what's going on in the Colorado River. And of course, we in Phoenix and Tucson and LA, Vegas, Denver, a lot of big cities, Salt Lake, San Diego, all depend on the water in the Colorado. So it's not a surprise that the New York Times said, holy cow, look what's going on with the Colorado River. Lake Mead has dropped precipitously since the late 90s when it was full. And this picture, of course, was last fall. You can see a couple jet skiers enjoying the lake. But this is how much it's dropped. Put that in perspective. It's a huge amount of water. About 60% of the water is there now. The other thing that's going on across the West, which is increasingly getting recognition because people almost can't miss it if you drive anywhere in the West, is forests are dying and forests are burning. And I'm not going to talk about this today, but if you go down into the desert, particularly the Mojave Desert, you're going to see desert plants also dying in perhaps unprecedented numbers. And why is this occurring? There are a whole bunch of reasons why you're getting mortality of trees. In some cases, it's pure out too hot and dry, such as the case of the pinyon pine in 2002 and 2003 in the Four Corners region. And that's down in this neck of the woods. In other places, indeed most of this area, you're getting trees that are getting so hot and dry that they're unable to fend off insects, in this case beetles. These are all beetle-related tree mortality or death. And at the same time, because it's warmer, the beetles can put out more populations, more generations in a year, and can become much more abundant. So it's really a poor, bad recipe for these trees, bad recipe for disaster. And we're starting to see this all over the West, particularly in the front, the Colorado Rockies and up here in BC. It's really eye-popping. And you can see this even in our own forests as you go up on the rim and further north. And we're getting unprecedented wildfire. I'm not going to show a slide of this, but the fire is increasing almost exponentially, if you know what that means. In other words, it's really increasing much faster than we thought possible. Okay, so I want to take a step back now and talk a little more about what's going on at the global scale and what it means for the Southwest. And we'll come back to some of the news we just talked about. Right? I'm going to focus on the news. I'm going to focus on global climate change. And then again, it's this poster child for climate change. I think a global poster child, but certainly for the United States, the Colorado River Basin. It's really important for us in Arizona to take this seriously and talk about what to do. It's not the job of scientists to say what to do. It's our job to say, here's what's happening, why we think it's happening, and here are our choices for action. But it's not our job to say, you must do this or that. That's the job of all of us as citizens. Okay? Perhaps one of the most interesting things in 2011 was a wind just a couple weeks ago. The numbers started to come in on the temperature for the entire 2010 year. And we learned that globally, the Earth broke another tie, the record for the warmest year ever in the instrumental record, the thermometer record that goes back into the 19th century. And this is a map of the anomalies for last year versus this base period 1951 to 80. And looking at this year of unusually warm temperatures, which tied 2005 or 1998, depending on who's compiling the numbers, as the warmest year, you can see a couple different things. One is, when you have an individual year that is like the warmest ever, that doesn't mean every place on Earth is the warmest ever. It means the average global temperature is the warmest ever. Some places in the Earth, particularly in the tropical Pacific, where we have a La Nina going on, that cools the Pacific, and that makes this 2010 even more unusual because we've never broken, the other 2 years when we tied the record, we had El Niños going on, which would warm us. Here we actually got a record-breaking year despite having this cooling going on in the tropical Pacific. You can see that the warming is greatest at the high latitudes, overland in the northern hemisphere. Keep that in mind. Remember this last summer? It was about 4 standard deviations, or just an incredible amount warmer than average. Okay, and that's why we had those big widespread fires in Russia and crop failures in Russia that are contributing to the commodity, the food prices going up, which we'll probably see in more dramatic consequences going into this year. All right. Now, this year was the warmest year ever. A lot of people still like on the web, the blogosphere, like to say, oh, the sun is what's causing climate change. And I thought it's important to point out that just 1 year ago, remember when we were having a lot of snow, just like this year, in the east, and people were building igloos, kind of joking on the mall in Washington, and they were saying, what happened to global warming? Ha ha ha. Well, it's winter, right? So it usually snows in winter. But the other thing that people were doing in the blogosphere is they're pointing out, oh, we're getting all this snow, it's cold in Washington, and you know why? It's because the sun has hit a low point in its irradiance record, in this 11-year cycle that the sun has. And so because it was so much less radiation coming from the sun, that's why it's getting so cold. Well, there are a couple of things about that are completely red herrings. First off, I want to point out that this is a record from NASA. This is the solar record, going back to the beginning of the satellite record. Because if you really want to measure solar radiance, you got to use spacecraft. And you can see this 11-year cycle, and there's a lot of variability around that, but basically the black and red lines show you the longer period trend. And the sun gets more irradiant, less irradiant, more irradiant, less irradiant. Right? And the overall amounts of radiation change on the Earth, no one in this room probably knows these units too well, it's a teeny amount. So climate scientists for a long time have said that's not enough to cause any appreciable temperature change on the Earth. Okay, but nonetheless, people in the blogosphere, non-climate scientists like to say it does. Okay? But here it is. We're at the low point of the cycle. And we're near the low point of the whole entire period. And yet, what happened in 2010? We got the warmest year ever. Okay? Notice also that there has been no trend in this record over this entire record. In other words, if anything, the sun has been becoming less radiant. You see, this peak here was higher than this peak here. So if anything, from 1975 to 2010, there should have been you should see this cycle, and it should have been a net cooling if the sun is actually playing a role. So here's the temperature record, going back to the beginning of the thermometer record, 1880, right? This is compiled by 4 different organizations around the world, including 2 in the United States, NASA, NOAA, plus this Met Office crew in the UK. Remember, they're the ones that got lambasted in ClimateGate for fudging the data. Isn't it, the scientists knew right away that that was false accusation because we knew that their compilation pretty much matched all the others that were independently done. But the important thing about this curve is to note that climate change isn't 1 year after the other, warmer and warmer. There's a lot of variation. There's ups and downs, ups and downs. There are periods of big peaks and then cooling for several years. Even in the last 10 years, things haven't warmed as fast as they did before, although they're still warming. That is because what we're doing is we have a human-caused trend of climate change, the global warming, and superimposed on that we have the natural ups and downs, the natural variability that we always have had and always will have. But that natural variability is small compared to the trend, and that's why over this entire record, on the scale of decades to century, scales of climate change, we've seen sort of inexorable warming. But let's go back to that solar record. Remember, it started in 1975. It was flat, or if anything, going down just a little. 1975, right here. What happened to the global climate over that period of observed solar radiance? We got the strongest warming we've ever seen in the record. All right? That's when the solar radiance was flat. And is there any sign of that 11-year cycle? No. No sign whatsoever. The only place you see any apparent influence, perhaps, of the sun is in tropical precipitation, rainfall. And it's a pretty small effect. But nonetheless, people still like to say, the sun is causing all this warming.